All right, let's do the first proof example on this foldable. Now this foldable, they should be easier examples, so hopefully you can do most of these on your own, but we will go over some of them. All right, so we're given that JE equals ET. Okay, well, hopefully by now you know that that is given. Okay, so next we're going to look at number 2. It says JE plus ET equals JT. Well, JE plus ET equals JT. Hopefully you guys know by now that is the segment addition postulate. Okay, now JE plus JE equals JT. So what the heck did we do? Well, notice this ET changed to a JE. Well, why did it change? Well, guys, we know that they're equal. Okay, so we can change them in and out, so we can substitute them. And I substituted line 1 for line 2. Substituted line 1 in for line 2. Okay, and then guys, if I simplify it, JE plus JE is just 2JE, just like x plus x equals 2x. So all I did here is I simplified. All right, guys, let's do another example. All right, so we're given that AC equals BD, so given. Okay, now if I look at this, I'm given that AC equals AB plus BC. AC equals AB plus BC. Guys, that's just the segment addition postulate. Okay, then I'm given that BD, so BD equals BC plus CD. That is also the segment addition postulate. All right, now we're going to kind of look at 2 and 3 together. Okay, so if I look at AC, okay, doesn't AC equal AB plus BC? And if I look at BD, doesn't BD equal BC plus CD? So what I'm going to do is I'm going to substitute here. Okay, for AC, I'm going to put AB plus BC, which is this part. Okay, for BD, I'm going to put BC plus CD right in here. So all I did is I substituted lines 2 and 3 into line 1. Okay, guys, BC equals BC. Well, you should know that. That is the reflexive property of equality. And the reason I did that is because here, if you subtract BC from both sides, you're left with AD equals C, or AB equals CD, which is right here. So this is the subtraction property of equality. All right, here's the third of these segment proofs. So what I want you to do is I want you to try to work this one out on your own, and then we'll go over the answers when you've given it a shot by yourself. All right, guys, go ahead and check what you have against what I have here, but this should be the right answer. All right, guys, let's look at the first of the angle proof. So it looks like this. So we're given here that 1 plus 3 is 180. So that's given. Okay, then we're given that angle 2 plus angle 3 equals 180. Well, guys, aren't 2 and 3 a linear pair? And don't we have the linear pair postulate that tells us that that all linear pairs are supplementary and equal 180? So we'd put linear pair postulate here. All right, now if I look at this, if I look at lines 1 and line 2 together, both of them equal 180. So Measure of angle 1 plus measure of angle 3 is 180, and measure of angle 2 plus measure of angle 3 equals 180. And therefore, since they both equal 180, I can combine them to say that the measure of angle 1 plus measure of angle 3 is equal to the measure of angle 2 plus measure of angle 3. That is the transitive property of equality. Two things are equal to the same thing, they're equal to each other. Okay, now angle 3 equals angle 3. Guys, you should know that as the reflection. Okay, so if I subtract angle 3 from both sides, I'm left with measure of angle 1 equals the measure of angle 2, which is exactly what I want. And that is by the subtraction property of equality. All right, guys, let's look at the second example for the angle proofs. All right, so measure of 1 equals measure of angle 4, and measure of angle 2 equals measure of angle 3. Well, those are right there and there. So surprise, surprise, first one is given. Okay, now notice, if I were to just take this here, okay, so just what's highlighted, compare that in line 2. Okay, how did it change? Well, if you see, this is just line 1, but I added a measure of angle 2 to both sides of the equation. Let me highlight this so maybe you can see it better. Okay, so when you add the same thing to both sides of the equation, that is the addition property of equality. Okay, now if you compare lines 2 and 3, the only thing different is this measure of angle 2 changed to a measure of angle 3. Everything else is the same here. Okay, and the reason I can do that is because I can substitute 3 in for 2. Right? So this is substitution. And I use line 1 in for line 2. All right. Now, measure of angle 1 plus measure of angle 2 equals measure of angle RSU. So if I look up here, 1 plus 2 is RSU. This is just the angle addition postulate. And then angle 3 plus angle 4 is VWY. This is also the angle addition postulate. Okay, now RSU equals VWY. Well, why is that? Well, let's go back to this line here. Okay, so measure of 1 plus measure of angle 2 is here and here. Okay, so I can substitute this in for here. Then measure of 3 plus 4 is right here and here, so I can substitute this in for this. Okay, so I can substitute, and I'm using lines 4 and 5 into line 3. And that is the second angle proof. All right, guys, here's the third angle proof. So just like the segment proof, I'm going to pause this. I want you to go through, try to figure this out on your own the best you can, and then I'll go and fill in the answers, and then I'll let you check to see if you got it correct. All right, here's your final proof all filled out.